I welcome everybody to today's class. This is Maths with Mr. Sam, and I want to endure you to watch this video till the very end. Don't go anywhere. Now, if you look at today's question is on a number-based system. Now, when we talk about number-based, what is number-based? Number-based simply defines or denotes how a number is being written, how a number is being represented. Now, when I talk about number base, of course, I'm talking about bases like base 2, base 3, 4, 5, 6, 7, 8, just name it. Now, when we are working on a number-based system, there's something we need to take note of. What are they? In this video, I'll be letting you know all of those things before we head into this particular question you can see on the board. Now, when it comes to a number-based system, you must take note of something very, very important. You know, I've seen many students go through this route and they end up making series of a mistake. Now, what is that? When it comes to a number-based system, please note that whatsoever you will be getting as your answer, or should I say, your answer must not be more than the base or equal to the base. What am I trying to say? If you are converting to any base, be it base 1, base 2, base 3, 4, 5, 6, name it as the case may be, you must note that your answer, whatever you'll be getting, should not be more than the base or equal to the base. Just imagine, you have to convert to a base 2 numeral, and what you got as your answer is 3 base 2. You are wrong. Do you know why? Because your answer is what? More than the base. And it states that whatsoever you will be getting should not be what? More than the base or equal to the base. Be it that your answer is 2, you are also what? Wrong. Because 2 is equal to the base, which is what? 2. Just like the saying goes, you can never have two captains in a ship. The same goes with this. I believe you understand that process now. Now, let me still let you know of something. When it also comes to a binary number and you are asked to convert from a base 10 numeral to any base. Take note, a base 10 numeral to any base. What are you meant to do? Very simple. You are meant to divide continuously to get your answer. I come again. If you are converting from a base 10 numeral, you are given a question in a base 10 numeral and you are asked to convert to any base, be it base 2, 3, 4, 5, you are to divide continuously using the base you are converting to. That's by the way. Now, what if you are being given in a base that is not in a base 10 numeral and you are asked to convert to a base 10 numeral? Maybe you are given a base 2, a base 3, a base 4, a base 5 numeral, and you are asked to convert that particular figure to a base 10 numeral. What do you do? Of course, the first thing is to do what? Expand it and give them a place value, right? Good. Then you multiply and then you add continuously till you get your final what? Result. That is when you are converting from a base 2 to a base 10 numeral or a base 3 to a base 10 numeral. But what if you are converting from one base to another base that is not in base 10? What do we do? Very simple, right? Now, to do that, what do you do? The first point is to convert that particular thing to a base 10 numeral. You convert it to a base 10 numeral, then from a base 10 numeral, you can convert to the base you want to convert to. It's just like a child who wants to go to school, right? Good. What does the child do? The child left his or her house, heads straight down to the bus stop. At the bus stop, you get a bus that will take you down to the school, right? So the bus stop there is acting as the base 10. Are we good to go now? All right, now let's come back to what we have on the board. On the board here, we have a word problem question on the number base. As you can see, it says solve 2K3. 2K3 base 5 equals 125 base 6. If you look at the board, we have two bases here, right? This is a base 5 numeral and this is a base 6 numeral. If you observe closely to the question, you will observe that in this base 5 numeral here, what do we have at the highest number for now? 3, right? And it will tell you that no figure here is what? More than the base or equal to the base. Good. Now, if you look at base 6, the highest numeral there is what? 5. It is not more than the base, and it is not what? Equal to the base. So we are good to go, which means that our question is actually what? Correct. Now, if you look closely at the left-hand side, you will observe that we have what there? We have an unknown alphabet there. We have an alphabet there, right? An alphabet is used to represent what? An unknown number. So we have an unknown number there, of which K is what? Representing. Are you with me? Okay, let's go. Now, in an algebraic question, when you see something like this, it simply means that what you have here is equal to what you have here. Right or wrong? Good. Now, in solving this question, what do I do? The first thing to do is to convert them to a what? A base 10 numeral. Make them to be of what? The same variable. Just like if we talk about ratio, right? And you have 2 centimeter ratio, 4 meter. What do? Before you can actually attain such question or get your answer, you must do what first? You must make them to be of the same what? Variable. So the same thing applies to this. Now let's go. What do? I'll bring down this. We have 2k5, 2k3 base 5. Now, like I said, when you are converting from any other base to a base 10, what did I say you do? I said you go with continuous addition and multiplication without forgetting your place value, of course. It's very important. Now, it will apply here because this is a base 5 numeral. I am converting towards a base 10 numeral. So I'm going to go first with my place value, starting with 0, 1, and 2. Right? Then we'll go this way. 2 multiplied by the base, which is 5, raised to the power of what? 2. Then addition, your plus, k multiplied by what? Your base, 5, raised to the power of what? 1. Do you see that? Alright, let's go. Then plus, what do we have next? 3 multiplied by what? The base, 5, raised to the power of 0. Remember, we are converting them to base what? 10 first. So we have having, bring that by 2 times 5 raised to the power 2. Most students make a silly mistake in this kind of question. They go 5 raised to the power 2. Some people will do 5 multiplied by 2 and then they have 10. So we go as 5 times 5 or 5 plus 2. No, which is wrong. 5 raised to the power 2 is simply expressed as 5 times 5, which means 5 in 2 places. So 5 times 5 gives you what? 25. Plus, bring down your k, multiply by 5 raised to the power of 1 is still what? 5. Then plus 3 times 5 raised to the power of 0 is what? 1. Anything raised to the power of 0 gives us what? 1. Now let's go. 2 times 25 gives us what? 50. Plus 5 times k. K times 5 gives us what? 5k. Then plus 3 times 1 gives me 3. I'm going to put this together. Remember, I cannot add 50 plus 5k. Do you know why? Because k is carrying what? An unknown. I can't add this together, but I can multiply it if I have a multiplication sign there. But there's no multiplication sign there. What do? I'm not going to add this. So therefore, in algebra, we say we collect like terms, right? Good. I will collect like terms here. This and this are both the same thing because they are not carrying an unknown. So 50 plus 3, that gives me what? 53. Plus 5k. I'm going to leave this. I will stop here. Then, do you know why? Because I cannot add these two together, right? I'm not getting the value of k. I am asked to look for the value of k. So I can't add this together. I will leave this halfway and then I will attempt this other one. 1, 2, 5, base 6. I will do the same thing, convert to base 10, and I will compare it to get my answer. Let's go. 0, 1, and 2. Do you see that? Good. So we have 1 times 6 raised to the power of what? 2. Plus 2 times 6 raised to the power of what? 1. Plus 5 times 6 raised to the power of 0. Good. Equals, remember we are converting to a base 10. Don't forget that. Bring down my 1, multiply, right? 6 raised to the power of 2. Do not make that mistake by saying 6 times 2. You are wrong. 6 raised to the power of 2 simply means 6 times 6. How many 6 can you see here? 2, right? That is 6 raised to the power of 2. So 6 raised to the power of 2 will give us 6 times 6. That gives me what? 36. Plus 2 times 6 raised to the power of 1 gives us what? 6. then plus 5 multiplied by 6 raised to the power of 0 gives me what? 1. Of course, anything raised to the power of 0 is what? 1. Alright, let's go. Then we have 1 times 36, that gives me 36, plus 2 times 6, that gives me what? 12. Then plus 5 times 1, that is 5. So what do? I'm going to add up all this together. 36 plus 12 will give me what? 48. Then 48 plus 5 gives me what? 53. So I have 53 base 10 here, right? Now I have succeeded in converting these two figures to a base 10 numeral. What do? Let's compare them together. For this is representing this, right? This is the final result for this particular one. So I have 53 plus 5k, right? Then what we have here equals to what? This is 125 base 6 is simply represented by what? 53 base 10 equals to 53 base 10. Now these two are now in the same base, so which means I can now do what now? Solve and get my k, right? In algebra, we talk about collecting like terms, right? Now what do? I'm going to collect like terms here. Are you with me? Because this k cannot be added to this. They are both different. This is carrying an unknown and this is not carrying an unknown. So what do? I will collect like terms, right? In collecting like terms, I will bring down 5k then equals to 53. Now when this one comes here, this is a positive number, right? Good. Now when a positive number crosses the equal to sign, it gives me a what? A negative number. Do not forget that. If a negative number crosses the equal to sign, surely I'm going to get a what? A positive number. So put that at the back of your mind. Meaning that for context, if a minus sign crosses equal to sign, it gives me plus. If a plus sign crosses equal to sign, it gives me minus, right? So this is just what I'm saying. Good. Now this here is a positive number. When it crosses, it gives me what? Minus 53. Then we have 5k equals to 53 minus 53. Of course, that gives me 0. So when I divide both sides by 5, what do we have? K equals to 0. So 0 divided by 5 gives us 0. So the value for k there is what? Is 0. So this is how you solve questions like this whenever you meet them. Do not forget what I said earlier, that whatever you get as your answer should not be more or equal to the base. I hope you learned something today. Please do not forget to like, share, and subscribe to this channel for more videos. I'll see you on the next one. Bye for now.